Hello and welcome to another video of Today You Learned. So last video, so this will be a follow-up on video part 1, where we were able to get some usernames and corresponding passwords for a company that is domain joined, right? It was iccc.be was the domain. So for more details, this is what we ended up with. Right, more details in, of course, part 1 of this series. So let's continue with these credentials. These are actually enough to make us log on to the dashboard of Office 365 or Azure portal, to be precise, where you can actually see some more details on the entire domain. We can, since we are actually a fully limited user, so I'm just logged in with this one, but even limited users have actually all the permissions to get a list of all the accounts, where we can even see that some have done multiple stuff with their accounts. We can actually even have a look at the groups. If we not this one, of course, right here, we can have the roles. So groups are not that heavily used on an Azure AD environment. It's more these are more important on on-premise environments, but right here we can actually see that there is only one typical main administrator, in this case application administrator, which is Chris Yellow. So just to prove that we are logged in as a normal user. Another way of using this or abusing this we could try our password spraying attack again, but now this time with all of the accounts. Maybe we will find an account that does have more access than our current A Winkle account. We also concluded actually with getting more information via PowerShell. So we can see that we were able to use reconnaissance, authenticated reconnaissance, to get more details on the entire environment. One thing I wanted to finish here is that we are actually able to actually get a list of all the users that have multi-factor authentication enabled. For example, if we know that, then we can actually, well, we know that we are not able to do anything with that, of course, since multi-factor authentication would be enabled. In this case, none of the accounts have multi-factor authentication enabled. And then for this video, we will move on-premise, which means, let's say that we have usernames and credentials, and we can use those to log in via VPN, so that now we have a machine, let's call it the machine that we are in right here, that we did have that one connected to the on-premise environment of that company, right? So this would be completely illegal without a pen testing agreement, of course. So one thing that is very interesting in any synchronized hybrid Azure AD environment would be that there would be an on-premise directory synchronization account that would always start with sync, and then we have a host name, actually, which is actually the name of the machine that performs the synchronization with Azure AD. And then this is a part of the username that is being used for the synchronization with Azure AD. So the full username, if I copy paste or copy this and I want to type the full username, it would be something like this: MSOL _ and then those characters. That would be the on-premise username, so it would look something like this. If the on-premise domain is also called iccc or iccc.be, that can of course depend a little bit, but if this is the case, then this would be the name of an account, the DN of an account that has sync permissions to retrieve all the objects and synchronize them with the cloud. Okay, so that would actually be our first. So the thing that we want to do right now, to summarize and to make a too long didn't read summary, so what for this video I have prepared is to find that account, we just did it, find that sync machine, then access that machine to get the full credentials, so not only the account but also the corresponding cleartext passwords, and then using those we can pwn the entire domain. And then the next part, we will actually use the user hashes to get access to an NTLM authenticated web interface. More details later, of course. So that's actually it for this one. So let's go on. Let's have a look. So the first step would be to get local. So let me open a new window. So this is our hacking machine. We are connected, let's say, via VPN. We have a subnet. Let's see if we can actually find the local domain. So one way to do that would be to use this one. So if this local domain is actually the same as the one that was used online, which is sometimes the case, often the case, we can just perform a DNS request, and then we can see that it is being sent to the local name server, the local DNS server, and that local name server has the name PDC01, which could indicate that this is a domain controller. So we have found a local domain controller. We can actually verify that. Since we have his IP address now, we can verify this by just performing an NS lookup of that IP address, asking that IP address, which just confirms it. So since we now have already credentials of Active Directory, right? Remember, we found them right here at the top of this, right? A Winkle. So we can actually just reuse these credentials on the local Active Directory. So we already have authentication on Azure AD. So let's try that out maybe on a different PowerShell with the local PowerShell command. So instead of get Azure AD user, we can now try to perform a get AD user environment for this machine that we just discovered, right? The primary domain controller or just domain controller. I will type in the credentials. So this will allow us to type in the credentials, and the things that I actually want would, if this account exists, well, let me ask some information on this account. So like this, and show me all the properties of this account. So this would be a more or less elaborate command to just get information on one simple account without actually having a machine that is domain joined, right? So this, I can just use this environment or just pop up to enter the credentials that we had before. So in secure 2020, and here we are. So I could just, of course, run just a normal get AD user to get a full list, but in this case, I actually have the credentials of an account that we already assumed would be present, because this is the account that is being used to synchronize the Azure Active Directory content via a software called Directory Connect. And it is running on a computer called SyncWink, which we actually already also knew based on what we saw on the portal, right? So let's see if we can get access to this environment or to this computer. So to get access to that computer, I would actually have to perform a DNS lookup once again. So instead of looking up an IP address, let me just look up the name without mistyping, preferably like this. So it is in the domain, luckily, and it is in the DNS. So this would be the IP address that we might try to get access to, right? So how can we try that? Well, let's see. We have one credential. Who knows? Maybe that credential actually has Active Directory permissions, right? So let me pull this up a little bit larger. Like this. So there is an easy and foremost very antivirus secure way of trying this out. Just try to get access to the share, right? So for example, A Winkle, we know the password, and you have to specify the domain, for example, like this. Maybe if this is the full domain, and then we connect to the PDC01. So this DNS seems to work right here. This would actually work. So as we can see, or use C, I believe, this does not work, right? We don't have the access rights to go to C#. So this means that this account actually works, right? I believe shares or something will list all the shares. So this works. This account is an Active Directory account, which you already knew, but it is not an Active Directory domain account. Okay, so this means that we will not be able to directly access this machine. So exit, right? So let's see if we can do something else using, maybe we have more luck when trying the same thing on our synchronization machine. So let's try it out. This seems to work better. So since we have access to the $C environment, this means that this account is probably local administrator on this machine, right? It's a domain account which has local admin permissions on that machine, which is not a good ID to configure, of course, but since this is a demonstration, let's abuse that. So we will now move on to premise. We will try to get access. Again, bearing in mind that we don't want to trigger unnecessary antivirus environments that might be present there. Let's just use the way that God or Microsoft intended it to, right? So one of the main ways that Microsoft likes to use is using PS Session, right? PS Session is by default, if you type it right, PS Session like this. If you type it correctly, this is by default enabled on any Windows Server machine, domain joined or not. So this will always work, at least if you have the correct permissions and if it's a Windows Server, not a Windows client. So let's get access to our sync wink. If I can type it correctly. Credential. Let's ask it up again. Why not? A winkle. If I'm not making any mistakes. Like this. Let's see if this works. It looks like it works. So now we have access to this machine. We have access to the documents. We can have a look at what is happening here. And the entire environment. And now we can run code. Okay, so this means that we now have access and we can run code, download stuff or extract stuff or do other stuff that is a lot of fun on this synchronization machine, right? This is the synchronization machine. We already know about an account, or we have an account that we looked at before. Where is it? The MSOL account. So what is the clue here? The clue is that this account is not only present on this machine, but the password is stored in an on-premise or a local SQL server of this environment. So let me show you how that looks like. I will now download something called a script, an Azure AD decrypt the MSOL account. It's actually a fixed version on that is, you can find it if you just go to gist.github.com/teldenode, then you will find this script right here. And what this script actually does is it addresses the SQL server and it extracts the username and cleartext password for the Active Directory synchronization account on this machine. It's very simple. Just have to run it like this, press enter. It takes a couple of minutes. It was of course originally developed by someone else. I'm not gonna have to reinvent the hot water, as they say. So this was the original guy, but I had to alter it to have a new crypto key storage method, and especially to make it work on server 2019. So here we are. It worked. So we have the domain name, which we already knew. We have a username, which we already knew. And now we have a password that has been, by the way, automatically created by Microsoft when Azure AD synchronization was set up. So when installing Azure AD synchronization on this machine, this account was created automatically. So this password as well, right? It's not a password that someone has typed in at any point in time. So this will always be this long and this difficult. Okay, what can we do with this password? Well, we can actually perform something called a directory synchronization of the entire Active Directory with this account, this password. So back to our Kali environment, because one other in-packet script, there are almost all in-packet scripts are worth having a look at, but one other one is called secrets dump. Secrets dump is actually can actually extract Active Directory environments and even hashes and stuff like that on local machines as well as on remote machines. So let's try to do this using the iccc.be domain, the MSOL, and I will probably be better off if I copy paste it, right? Underscore like this. On the primary domain controller, which should be this one, right? I didn't specify the password because it's probably easier to just copy paste it in that new field. Otherwise we would have to escape several of these stupid characters. So by doing it like this, I don't have to escape them. I can just copy paste them. And here we go. We now have a full dump of every single Active Directory account or object, including the hashes, right? So yeah, this clear text we already know, but now we have, for example, Richardson, his password. We have the domain administrator, like this. So we are now full domain admin. If you want some proof that this actually works, well, I can actually open up a new one like this. You know about crackmap.exec, I presumably. So this would be the IP address of the primary domain controller. This is the administrator, and this is the hash of the domain administrator. So we are fully domain admin, and we can do whatever we want. So that ends the first portion. The next portion is actually a little bit cooler. It's actually already open here, so let me close it. So the next portion would be to try to get access to a website that uses NTLM authentication, and of course I would have to type that correctly. So this is NTLM authentication, right? So this means that if you have a pop-up like this and it expects a domain credential, which it usually does, we can actually perform something called a pass the hash. What is a pass the hash? It's something we actually just witnessed right here. We were able to authenticate to a machine using its hash or the user hash instead of the cleartext user password. So how would you go about and do that, for example, for a specific user? So first we need that username. So let's take this one, and then its corresponding NT hash. So this is the wrong hash because it's all the same on all machines. So this would be the user hash. And then we need another tool, and that tool is called Mimikatz. So let's open Mimikatz, but for that I will have to start a new command prompt as administrator. These are not running as administrator. Why is that? Well, let me first open it up a little bit, see if I can log in a little or zoom in a little bit. So Mimikatz, I want this environment to run in with debug privileges. That's to have access to memory spaces or memory space that is not its own. And to be able to run this command, we have to be administrator on that system. That's why I had to open up a new command prompt. And then we need a very interesting command to perform that so-called pass the hash. So let me copy paste it just to be sure I don't make any typos. So pass the hash for this user, then this would be his NT hash or NTLM hash. This would be the domain, and then once he has performed the pass the hash, run something called Internet Explorer. So that's actually why I have Windows 10 around sitting here, because that environment, Windows 10, actually does have Internet Explorer present, whereas Windows 11 does not. Why is that important? HTTP pass the hash only works with Internet Explorer and not Edge or Chrome or something else, at least to my knowledge. What do we need to get it to work before we continue? Well, we first have to go into, I believe it was security, and then you have the local intranet environment, sites, and then we need to add, we can use wildcards, but we need to add the domain or the website as part of the local intranet. This means that Internet Explorer will treat any and all websites here as being a local intranet, allowing it to use cached NTLM credentials without having to type them all over again. So this is what is required to allow us to perform the pass the hash. So if I now visit that website without asking for a password, I am now automatically configured or authenticated as this user. And we have something new, and that will be the third part of the video, where we can actually open up a VNC session to another device and then log in and continue from there to do some more nice stuff, right? So this concludes this video, or this part of where we started from Azure AD and then moved on to the on-premise part. With some lucky features right and left, we were able to get a domain admin and even replay some hashes. Okay, keep learning.